Is it possible to find a motherboard for Ryzen 5000 series CPUs which doesn't compromise on performance and allows even using two Gen4 M.2 NVMe SSDs simultaneously without limiting their throughput, and at the same time costs under $200 US? Well, it is, otherwise I wouldn't be making this video. I went through all B550 and X570 boards at this price range and ended up with this Gigabyte X570 Aorus Elite. When I found out that I'm able to get X570 board at this price range, I threw away all B550 boards from my list because they compromise on performance when it comes to connectivity from the chipset to the CPU by 50%, which is too much. So that's the main reason. Then when I looked at this board's VRM, which is 12 phases and it's solid, it allows even using Ryzen 9 5950X without any problems, I was halfway sold. And when I looked at complete layout of this board, I was sold completely. Not that other features would be unimportant, but these two are at top of my list. So let's not waste any more time and let's take a look at this motherboard in more detail. What you get inside the package is a motherboard, user's manual, two quick installation guides, special Aorus sticker, CD with drivers and utilities. I don't know why they still enclose these, because the latest drivers and utilities always have to be downloaded from the website. You'll go there anyway to download the latest BIOS. Then we have here four SATA cables, one M.2 screw and one M.2 standoff. These are for the second M.2 socket. The first one has these already pre-installed. And the last one is this G connector, which is for connecting the cables from the case to the motherboard. Let's take a closer look at the enclosed SATA cables. All of them are 50 centimeters long. First two have straight SATA connectors, and the other two have 90-degree connectors. Now it's time to remove the plastic. Finally, we can start with the rear I/O. As you can see, the I/O shield is integrated, which is definitely a plus. Even some more expensive boards don't have this integrated. Here are four USB 2.0 Type A ports. These are mainly for peripherals like mouse and keyboard. Next to them is this HDMI output, in case you want to use this board with an APU, which is a CPU with integrated graphics. I guess that most people using this board aren't going to use it because they are buying this for performance, which is something an integrated GPU doesn't offer. But in case you do, it offers maximum supported resolution of up to 4096 by 2160 at 60 Hz. Next to it are these four USB 3.0 Type A ports. which means that they run at 5 gigabit speed. The white one, this one, can also be used for BIOS flashback in combination with Q flash button on the motherboard. It is a cheaper version of this button. It is not placed on the rear I/O, but it's located at the bottom part of the motherboard, therefore it is a little bit less convenient. But from a functional standpoint, it works the same, and you'll probably use it only once during the whole lifespan of the motherboard, right before the first installation of the CPU. It allows you to update the BIOS even without powering on your PC and even without having the CPU installed. There is a good chance you might really use it because the pre-installed BIOSes on all motherboards are usually outdated. This is caused by a time gap between the production of the motherboard and its distribution to the seller and the final delivery to you. This process can take even several months. Next to them are these two USB 3.2 Gen 2 Type A ports, which means that they run at 10 gigabit speed. These are the best ones to use with external SSDs or any fast external storage if you're using it. Above them is this Intel i211AT gigabit LAN port. And last but not least are these audio connectors. The bottom one is an optical digital output, and next to it are these 5 HD audio jacks which are connected to Realtek ALC1220 audio codec. It's fine, but it's nothing special, so if you have a standalone sound card, I'd definitely use it. When we look at this side of the motherboard, we can see metal VRM heatsink, which is big enough to keep it cool. The VRM is 12 plus 2 phases. This was achieved by 6+1 configuration using doublers. VRM is using IR35201 controller and the phase doublers are IR3599s. It's able to handle any 3000 series or 5000 series Ryzen CPU, including Ryzen 9 5950X, so there's nothing limiting your potential upgrade path. Let's try putting a large air CPU cooler like Zalman CNPS20X on AM4 socket to see if it interferes with VRM heatsink. As we can see, it doesn't interfere. There is plenty of space here, and let's try the back one. Yeah, there is still plenty of space. So it's usable. The height of the VRM heatsinks doesn't interfere with big high-end air CPU coolers like Noctua NH-D15 or Zalman CNPS20X. I have already done one build with this motherboard using NH-D15, so I know that it works. This is an AM4 socket. It supports 2nd gen, 3rd gen and 4th gen AMD Ryzen CPUs. If you wanna use 4th gen or Ryzen 5000 CPUs, you'll need to update the BIOS. The PCIe bandwidth is dependent on the CPU installed. Using 2nd gen CPUs, or in other words Ryzen 2000 series, will disable its PCI Express 4.0 capability, so I wouldn't recommend using them. The main reason for buying a motherboard with X570 chipset is PCI Express 4.0, so it wouldn't make sense. In other words, you should pick from these CPUs. If your budget allows it, go for Ryzen 5000 series, which have both higher IPC and clock speeds. The motherboard has 4 DIMM slots: A1, A2, B1 and B2. They support DDR4 memory modules. Maximum overall supported memory capacity is 128 GB. 32 GB single DIMMs are the max. ECC memory modules are also supported. I recommend checking QL first to make sure that the ones you chose are compatible. If you're using only 2 memory modules in dual channel setup, you should place them in slots A2 and B2 according to this scheme on the motherboard. You cannot use dual channel memory setup with 1 or 3 memory modules, and in my opinion you shouldn't use single channel at all because it has dramatic impact on the memory throughput of the whole system and it would cripple it, so use only dual channel. Now let's take a look at the top side of the motherboard. Let's zoom in a little bit. When we look at the top side of the motherboard and when we start from the right, we can see a 4-pin PWM system fan header. Altogether, this motherboard has 4 of these PWM fan headers. It's not much, but it's enough if you use them efficiently. All of them can be speed controlled according to the temperature from the temperature sensors, which are displayed in red on this scheme. What I would do is to use these Y split cables to increase the number of fans which can be connected simultaneously to the motherboard. Some manufacturers like Noctua even enclose these Y split cables with their coolers. You can of course get them separately. I think 2 of them cost around $8. For this motherboard, I'd connect one here and second here, which would allow me to connect 6 fans simultaneously. Now let's take a look at the right side of the motherboard. Here are 2 RGB LED headers, one non-addressable and one addressable. Altogether, this motherboard has 5 RGB LED headers, 3 non-addressable and 2 addressable. You can control RGB LED lighting using RGB Fusion 2.0 software in OS. It also allows you to control the LED lighting which is already installed on the motherboard. But if you don't like the LED lighting, you can switch it off, of course. Here is the main ATX 24-pin power connector. Not too far from it is this USB 3.2 Gen 2 header. You can connect your front panel case cable here. If you haven't bought a PC case yet, I'd recommend you buy one which has USB 3.1 or USB 3.2 Gen 2 front USB-C port. Remember, you want the one which has Gen 2 port, not Gen 1. If you're interested, you will find the test of USB-C Gen 2 external SSD cases on my channel. They can be used for quick data transfers or a backup. And the last ports on this side of the motherboard are these 6 SATA ports. The numbering is visible on the PCB. As you can see, it starts with 0, not 1, from the top right hand corner with this port. It is important if you're setting up a RAID array. All of them support RAID 0, 1 and 10. If you want to know more about it, you can watch my RAID special video, which can be found on my channel. SATA SSDs are still interesting if you get a good deal for them. They run cool, consume very little energy in idle, and are faster and more reliable than hard drives. They are good for general storage. Let's move on to the bottom part of the motherboard. Here is a front panel header. It's for connecting the wires from power switch, reset switch and case status LEDs. This is where you connect this G connector, which is part of the accessories of this motherboard. Make sure you match pluses and minuses correctly when connecting it to this connector. I'll put it there now. It has no resistance, so it's easy. When you have wires connected to it, it will be harder. You'll have to press more, so I'll take it out. Above it is this clear CMOS jumper. It allows you to clear and reset the system parameters to factory defaults. If you want to use it, you will need to turn off the computer and unplug the power cord. Then use a jumper cap or a screwdriver or anything metal to short the pins for a few seconds. If you use a jumper cap, remember to remove it after clearing the CMOS. And also, one other thing after clearing the CMOS is that you have to boot up the system to BIOS and load the optimized defaults before you can start using it. Here are two USB 3.2 Gen 1 headers. Each can provide up to 2 USB ports. Next to them are these two USB 2.0 headers. Each can also provide up to 2 USB ports. Close to them is this TPM header. TPM stands for Trusted Platform Module. It is a microchip which provides hardware-based cybersecurity and authentication. If you want to use it, you must have one. This one has 11 pins and one blank. Next to it is this empty space, where probably should have been a Thunderbolt header, but the manufacturer decided not to use it. It's not strange at this price point. It would have made this motherboard more expensive, because it would mean not only adding this Thunderbolt header, but also paying license fees to Intel. So its presence is a little bit odd. Here is a QFlash Plus button, which you already know. It allows you to update the BIOS without CPU installed. Above it is a small QFlash LED, which will blink during the BIOS update. Because I already spent so much time on it, I have decided to add a bonus to this video, so you'll see CPU list BIOS update at the end of it. Next to it are these two RGB LED headers, one non-addressable and one addressable. Next to them is this undocumented connector labeled LED demo. You won't find it in the manual. It features a micro JST 125 2-pin connector. It's for an external power input to illuminate the LED capabilities of the motherboard without actually having to power it. My guess is that it's for viewing purposes at a show or a shopping window, or for testing the RGB before it leaves the factory. If you power it, it cycles through RGB colors on the motherboard, and it requires 5 volts. And the last header on this side of the motherboard is this front panel HD audio header. The red capacitors above it belong to the audio. When you look at the motherboard from this point of view, we can see two headers. First one is the CPU RGB LED header, and second one is a fourth system fan header. I'd use it for connecting the exhaust fan at the back of the case. Then we can see here these two PCI Express 4.0 X16 slots. The first one is reinforced by metal. Gigabyte calls it ultra durable PCIe armor. This extra anchor is supposed to improve safety when installing heavy graphics cards, which can be handy. So this is the slot where you want to put your GPU. It's connected directly to the CPU by 16 PCI Express 4.0 lanes, so it will allow you to run it at full speed without any bandwidth limitations. The PCI Express 4.0 slot under it is X16 in length, but runs only at X4 speed effectively, because there are only 4 PCI Express 4.0 lanes leading from it to the chipset. From the chipset, there are other PCI Express 4.0 lanes leading to the CPU, which means that it's not connected to it directly. It also means that it's sharing this bandwidth to the CPU with M.2 socket, with two PCI Express 4.0 X1 slots, and with all SATA ports. Under it are these two PCI Express 4.0 X1 slots, which are not reinforced by steel. They can be used for devices which don't require a lot of bandwidth, like sound cards, Gigabit LAN adapter, or an additional SATA or USB controller. Then we have here two M.2 PCI Express 4.0 connectors for fast Gen4 NVMe SSDs. They support Gen 3 drives as well. The first connector is covered by a metallic heatsink with pre-applied thermal pad. Gigabyte calls it thermal guard. It is connected to the CPU directly by 4 PCI Express 4.0 lanes, and it is the best one to use with an M.2 SSD where you install your OS. This connector is in sharing bandwidth with any other slots or sockets. So let's remove the heatsink and let's take a look what's under it. Let's take a look at this M.2 heatsink more closely. It weighs 31 grams, so it's kinda heavy for how small it is. It is good because it's good for the heat dissipation. M.2 drives run hot. It's protected from the back. The back side has this thermal pad on it, which is protected by a plastic cover, which you'll have to remove before using it. The first M.2 connector supports 4 sizes of M.2 NVMe SSDs: 2242, 2260, 2280 and 2210. 22 is the width of the drive and 110 is the length, all in millimeters. The second M.2 connector also supports 4 sizes of M.2 NVMe SSDs: 2242, 2260, 2280 and 2210, but it's not connected directly to the CPU like the first one, but it's first connected by 4 PCI Express 4.0 lanes to the chipset, and from the chipset to the CPU by 4 PCI Express 4.0 lanes. This means that it's sharing this bandwidth to the CPU with second PCI Express 4.0 X4 slot, with both PCI Express 4.0 X1 slots, and with all SATA ports. And now comes the explanation why it is better to have a motherboard with X570 chipset rather than B550. If you had a motherboard with B550 chipset, those 4 PCI Express lanes from the chipset to the CPU would be PCI Express 3.0 and would therefore be limited to a bandwidth of 3.9 GB per second throughput, which is exactly 50% of what X570 chipset offers, which uses PCI Express 4.0 lanes, which is 7.8 GB per second. My assumption is that most people aren't buying this motherboard just for 1 year and are going to keep using it for much longer. The prices of Gen4 SSDs are going down all the time. The second wave of Gen4 M.2 NVMe SSDs is already finding its way to the market now in early 2021. So limiting your upgrade path by using PCI Express 3.0 connection to the CPU in case of B550 chipset is not a good idea. And if you wanted to add a third M.2 NVMe SSD by using an expansion card like this one, which this second PCI Express slot is more or less meant for, depends on what you want to use it for, this bandwidth would be bottlenecking your user experience even more. On the other hand, one thing you need to keep in mind is that most people, me included, only very rarely read from or write to more than one drive at the time. So the fact that there are more devices or more drives connected to the chipset simultaneously doesn't automatically mean that they are being limited by it. This happens only when these drives are reading or writing simultaneously at their full speed, which has to exceed the bandwidth of those 7.8 GB per second. And this happens only very rarely. And the last thing we need to talk about is this heatsink for the chipset, which is quite large, which is a good thing. The fan for the chipset is rated for 60,000 hours or 6.8 years of operation, and it can be speed controlled. It has 3 modes of operation: silent, balanced and performance mode, which can be all set in BIOS. And it is one of the first things I would recommend you to do if you buy this motherboard, right after updating the BIOS to the newest version, of course. One of the main reasons why I like the layout of this board is the size and placement of this chipset heatsink, which has a fan placed very far from the first PCI Express X16 slot, So even if you place a large GPU like GeForce RTX 3080, 3090 or Radeon 1600 XT, 6900 XT, the fan will still not be covered by them and will still have the possibility of sucking air from the case rather than the hot one from underneath the GPU. And before we turn the motherboard to the other side, let's address the ERP redesign. ERP stands for Energy Related Products. Sometimes EUP shortcut is used, which means Energy Using Product. European Union has decided to establish a regulation which defines the power consumption of the completed system. It states that the AC power of the completed system shall be under 1 watt in off-mode condition. The stricter version of this standard, ERP EUP 2.0, lowers this requirement to 0.5 watts. The practical outcome of this regulation is that you can enable this ERP feature in BIOS. Of course, you need to have an ERP-ready power supply. If you do that, it will start saving you energy, but it will also disable some wake-up functions in S5 state, which stands for shutdown. And these are PME event wake up, power on by mouse, power on by keyboard, and wake on LAN. So if you don't use these wake up possibilities, there is no reason not to enable this function in BIOS and save some energy when your computer is in standby. Let's turn the motherboard to the other side. As I'm holding it, my inbuilt weighting mechanism is telling me that it weighs 1060 grams. The backside doesn't have a metal backplate, so be careful when handling it inside the case. Put it directly on the standoffs. The AM4 socket's backplate is made of metal and looks sturdy. And I think that's pretty much it what we can say about this board. So let's move on to the BIOS update. I'll plug an empty flash drive to my USB port. Then I'll open the File Explorer and right-click on my flash drive to check if it's formatted to FAT32 file system. If it's not, like in my case, you'll need to format it. Before you do this, make sure to back up all important data on it, because formatting the drive would delete it. Now I'll choose FAT32, quick format, and press start. Flash drive is ready. Now I need to download the latest version of BIOS, which supports Ryzen 5000 series CPUs from Gigabyte's website. So I'll launch Edge browser. At the time of making this video, the latest version of BIOS available was F33C, so I'll download it. I'll click at Open File to open downloaded zip file with the BIOS, and I'll close the browser window. Inside the zip file, I'll find the BIOS file X570 AE.33C and drag it directly to my flash drive. This will uncompress it and copy it there simultaneously. I'll click at the drive letter to see if it's there, and then right-click on the BIOS file with my mouse. Now we need to rename the file to gigabyte.bin. This is required if you want to do a CPU-less BIOS update, or in other words, using qflash plus function. Now that the flash drive is ready, we can move to the hardware part of the process. The first thing I'm going to do is to take the motherboard and put it inside the case on these standoffs and screw it in so that it doesn't move when I'm plugging power cables to it. What I can do now is to plug this 8-pin power cable and 24-pin power cable. Now I'm going to take both power cables, the 24-pin and the 8-pin, and I'm going to connect them to the motherboard. So I'll start with 24-pin. And now the 8-pin. And now it's time to connect the power supply. Now I'll take the power cord and plug it into electricity. Then I'll take the other end and plug it into the power supply. Now I'll turn on the electricity, and now I'll turn on the power supply. Now I'll take the flash drive with the BIOS and plug it into the white USB port. Now I'll press the Q Flash Plus button and the BIOS will start updating. This type of BIOS update, the Q Flash Plus, makes sure that your motherboard will work with Ryzen 5000 series CPUs before you install them. It works only without CPU installed in AM4 socket, so do not put it in. Let's do it. Blinking of the LED stopped, so now I can unplug the flash drive. Updating the BIOS is finished. Now that the BIOS is updated, you can install the CPU, assemble all PC parts together, boot up into BIOS, load the optimized defaults, and you're ready to go. If you have any questions about this motherboard, please leave them in the comments below this video. I'll do my best to answer. And I think I've talked enough, so thank you for watching and see you in the next one.